Hello, this is Carl. In this video, you will learn how to read the schematic diagram for a complete load-sensing hydraulic system. And on the right-hand side of our diagram, you see a complete multi-section valve bank. This is a valve bank that has two complete directional control valves. The bars on each side of the directional control valve symbols let us know that these valves are proportional in nature, meaning that not only are they directional valves, they are also flow controlling valves so that we can have those two hydraulic motors turn at just the speed that we desire. Just before we go to animate mode, let me point out that we will be adding to the symbols for the motors our very own brake shoe brick stackers. And those brake shoe brick stackers are there to help conceptually understand why pressure might increase or decrease as we add or subtract bricks from those stacker platforms. More to the center of the schematic, you see our hydraulic pump. It's a variable displacement pump that is currently in the off-stroke position. Well, you see it actually moving the swash plate back and forth between 0 and 2 degrees. And currently, our directional control valves are closed. You see that T-shaped valve blockage on those two right-hand directional control valve symbols. So there really isn't any demand for flow. We're not asking for the motors to turn. So the pump moving between 0 and 2 degrees is just making up for internal leakages in the system and holding our pump outlet at port B on the pump symbol at our standby pressure, which will be a fairly low value, such as 300 psi. You see on top of the pump symbol both of the control valves or compensators that are common to a load sense capable pump. You see the pressure compensator, the lower of the two control valves. That will be set for our very top system pressure. And then above that, we see the load sensing compensator, sometimes referred to as the flow compensator. That's the one where the spring will be set for that low standby value, such as the 300 psi that I just mentioned. Let's make the system active by moving the left-hand proportional valve away from its center position and start producing flow through our left-hand hydraulic motor. I'll move it slowly, but I'll move it all the way to the full flow position so that you can see exactly which flow envelope we are using. But in reality, that valve could be anywhere from the center position to the full position, allowing us to control the speed of that hydraulic motor. Let's add a second brick to the stack and notice our pressure increase. And now let's make our second directional valve become active, our more right-hand valve. Again, we'll move it to the full clockwise flow position. And this time what I'd like to draw your attention to is the shuttle valves. There's one currently with an orange value pressure, a greater pressure because of the two bricks, and the one on the right has only a yellow pressure. It's the lighter pressure with only one brick on our brick stacker. Watch what happens to those two shuttle valves, and they're sometimes referred to by some manufacturers as ball resolvers. Watch what happens. Those are tiny passages that instruct on the LS line. Note the LS port as it leaves our valve bank. That is a signal hose that lets our pump know that it needs to increase its outlet pressure and perhaps displacement as well. Let's add a second and third brick to our right-hand hydraulic motor and observe what changes about the positions of those two shuttle valves, those two ball resolvers. Here we go. Second brick, third brick, and I think things change. Did you notice that at the addition of the third brick, that the more left hand of the two ball resolvers moved downward, making sure that the heaviest loaded section of our valve bank, which is now the right-hand section of the valve bank, has a clear path through to instruct the pump about the heaviest pressure in the hydraulic system. The only other major feature that we didn't speak of is the relief valve that is present at the pump inlet section of our valve bank. But since we're using a pressure compensated and load sense capable pump, this relief valve section should see very occasional, if any use at all. Our pressure controls are handled at the pump. That's all for this time. Thanks for watching.